This is video 2 for cosine rule, so obviously you can't really get the most out of this if you haven't watched video 1. So go back and watch video 1 first. Don't be silly, do the right thing, do it in order. In this video we're going to look at two examples. Find the length of the third side of this triangle correct to 2 decimal places. So we have a non-right angle triangle, which means it's a good candidate for the cosine rule, especially considering we're given two sides and an included angle. So we're given two sides and an included angle. So from the previous notes, that's a good time to choose the cosine rule. So we write down the rule. We need some letters first, so I've named the points. They weren't named. I've named the vertices A, B and C, or the angles A, B and C with uppercase letters. Make sure you do that if you need to as well. So we get stuck into the question. We first determine what are we trying to find. The third side, well, we know that one, we know that one, we need to find this one here, and because it's opposite angle C, we'll call it side C, lowercase c. So we're going to use c squared, lowercase, equals a squared plus b squared minus 2 times a times b times cos of angle C. Next we're going to substitute the values into the equation. So a is 3 because it's opposite angle A. B will be 2. So we have 3 squared plus 2 squared minus 2 times 3 times 2 cos of 102 degrees. Then we substitute all of that into the calculator. Three squared plus 3 squared plus 2 squared minus 2 times etc, etc. So there we go, and we're in make sure we're in degrees mode for that. It's very important, and we get 15.4949. Make sure that you enter it all correctly in. As an optional safety thing, you might want to put brackets around this section here, from here through to here. So you can put that in its own set of brackets too, if you want to be sure you're getting the right answer. So we enter the answer in from the calculator. Be careful, that's not the final answer. It's c squared, so we've got to take the square root. So taking the square root of 15.4949, just grabbing a calculator, you get 3.94 centimeters to 2 decimal places, because it asks for rounded to 2 decimal places up there. Example 2 now. A purely worded question, so we need to create a diagram for this one. A triangle has side lengths of 5, 7 and 8 centimeters. Find the measure of its smallest angle. So we've got to find an angle this time, and we've got to draw this triangle, and we mightn't really know the shape, so it is a rough drawing only. So let's have a go at that, and voila, there's a drawing. Okay, and you need to label the vertices, i.e. label the angles. Doesn't have to be like that, but that's how we've done this one. And you need to mark the side lengths on. So we've got side A, B and C marked on there. Again, the labeling is up to you. Once you've got the labeling for the angles on the sides, you need to find the smallest angle. Now, just like the hypotenuse on a right angle triangle, yes, I am talking about right angle triangles for a second here. The hypotenuse is the longest side, and you know that it's opposite the right angle, which is the biggest angle. Now that's no accident. Biggest angle. And in fact, on any triangle, not just the right angle one with the hypotenuse, if we have the longest side, it corresponds with the biggest angle. So we're after the smallest angle. So what would correspond with the smallest angle? Have a think. Which side? Well, it's the shortest side. So the shortest side will be opposite, would be in the opposite position. So opposite. So in other words, we know that the shortest side is 5, and opposite wherever 5 goes is the smallest angle. So it'll be there. So now we're ready to use the cosine rule, because remember, when you're given 3 sides, that's also a good opportunity to use the cosine rule. So which version do we use? Well, we're after angle B, and you know that angle B will be at the end as cos B. So you're going to use the version of the formula that has cos B at the end, which is the one that starts with B squared. So B squared equals A squared plus C squared minus 2 AC cos B. So let's sub the values in now. We've done all the thinking for now. So we've got A and C. So we got 7 squared plus 8 squared plus 2 times 7 times 8 times cos of B. Now B is still unknown, that's what we're trying to find, so all we can write there is cos B, but of course on the left hand side of the equal sign we know B squared is 5 squared. So we're going to have to do a different sort of approach algebraically here, because we've got different a different unknown in a different position. So what you can do then, you can either calculate and then rearrange, or rearrange and then calculate. That's up to you. Perhaps more people can follow calculate and then rearrange. So that's what I'm going to do. So we're just evaluating all of these amounts. So as we solve the equation, we want to get closer and closer to finding out what B is. So we need to isolate this term here, and then isolate this next term here, and then lastly isolate the B by itself. So how do we isolate this whole term here? Well, if we add it to both sides, if we add it to both sides, it disappears off the right side because it is undoing the minus there, and it pops up on the left side. We also need to subtract 25 from both sides as well, so that we only have 112 cos B by itself on the left. Okay, so you can see I've written down the steps of what we're doing, so you might need to pause it and follow it through, or replay this part. So let's go ahead and do those steps. Now we can evaluate the right hand side. So we've got 112 times cos B equals 88, so we need to undo the times 112 with dividing 112 on both sides. Alright, so I've written the step there just to help you out, and let's go ahead and do that now. So we have cos B on the left because we divided it by 112, and we must do the same to the right hand side. So let's evaluate that, or you could just hold off on the evaluation, which might reduce the rounding error and just take the inverse cos of both sides. And just keep this quotient in the brackets. It's probably a better way to go. Okay, and I've written the steps there. Let's now evaluate that for the calculator. Make sure in degrees mode. So I get 38.21 degrees to 2 decimal places. So the smallest angle is 38.21 degrees.